minus 1 minus x over 5, both will be half. Both will be half. 0.5, and when
5 meter.
sorry 5, it will be by1.
No, by 0, by 1.
0 and 1.
0 by1. No, the opposite. Teacher, the opposite. I said by1. by
0.
1.
X is when 7.5, then
Minus 0, minus half.
half
Yeah.
and
1.5.
when x is
Minus 1.
Minus 1.
2.
And then there's a more.
That's me. Okay. So this will be the influence line diagram for this beam. For this beam,
For B only for direction.
let me add a new slide. Example, if this is the beam, meter, 5 meter. So how will be the influence line diagram for A or B or both? Just put the values when x is 0. This is for AY, ILD.
Yeah, maximum 1.
And this is ILD for
A1.
so it will be
1 and 0.
1
Yeah.
and here it will be
0.
and here it will be
Minus 1.
Yeah, minus 1.
minus 1 and 1. And what about BY?
Opposite. Increase.
2. 2 and 1 and 0. So it means it is not always same. It depends upon the location of support. Where is the support? Like, okay, this is for the shear force. So any question about the ILDs for reactions? Because there are 3 types of ILDs. Number 1 for reaction, for shear force, and for bending moment. So we have done for reaction, and now we are going to talk about shear force. Okay, do you understand this diagram?
Yes.
Then no need to explain English the shear force. This is the ILD for shear force at a specified point, and that point is this one. So what are these? It is the influence line diagram. For example, this one. This is the influence line diagram for section or for point this 1 1. Okay, this one, the first one. And this diagram is the influence line diagram for section 2 2. How many of you understand this diagram? Would you mind to explain it? So first let's go back to the same example, a beam. Now what is the required? The required is we have to draw the shear force in first line diagram at point C. Okay. Anyone who want me to stop here? You?
No, I want to extend it.
Okay. All.
There is no external force here.
There is external force. The concept is same. Okay, I do it. Please see here. I make it very quickly for you, or we can see it from here. When the load is at point,
It would be maximum when the load is acting on it, right?
yes, maybe.
Alright.
See this table. This table gives you the shear force at point C when the load is at 0, minus 2.5, plus 2.5, 5, 7.5 and 10. What is this? I explain it to you right now. For example, this is your beam. The beam length is 10 meter. 10 meter and the point C. This point C is at 2.5. 2.5 meter. So we have to draw the inference line diagram for this point C. This is C. Okay, what I do, I have two choices. Number one, either to make the function or put x is equal to 0, draw the diagram or find out the value. Do you understand?
Yeah.
When the load is here at x is equal to 0, okay, let's make function first. I put the load here. The load is here, 1. And this distance is x. How much will be the shear force at point C? Very easy.
Is it in the middle?
If the load is here, how much will be AY? One minus x over 10
Yeah.
and by x over 10. So, if the load is here, or the load is just before this point, so how much will be V? Just apply sigma Fy. It will be
1 minus x over 10. Yeah. 1 and 1 cancels out. Yeah, 1 and 1 cancels out.
It will be minus x over 10.
You tell me the other way.
So it would be x over 10.
It will be reaction minus this load.
Yeah.
1 minus 1 x over 10
Minus 1. Minus 1. Yeah.
minus 1.
It will be minus x.
It will be minus x over 10.
Wait, apply sigma Fy. It will be, yeah, exactly. Minus x over 10. It should be positive.
No.
Okay. When the load is,
Teacher, it's correct if like the distance we're taking it like to the left is a negative distance, to the right positive distance.
okay, let's see what happens. Okay, if x is 0, now put the value in that equation. This is when x, now please take this thing that the load is on the left of this, but when the load will be on the right, this is when x, this equation is valid when x is
From 0 to 2.5.
0 to 2.5. Because as the load will move on the right of this point. For example, when the load will come here, then what will happen?
It will be x over 10 minus 1.
When the load will be here,
It will be from
so how much will be V? This is 0 to 2.5 when the load is here. But when the load is
From 2.5 to 10.
2.5 to 10, then at point C, how much will be shear?
1 minus x over 10.
It will be equal to this reaction.
Yeah.
Yes.
1 minus x over 10. So it means this is from 2.5 to 10 meter. It means at 2.5 you have two values. Now when you put x is equal to 2.5, you will get minus 0.25. It means that the shear just before point C and just after point C it is different. It means at point C at 0.0001 meter plus minus you have different values. Just keep this thing in your mind. Now so it means from 0 to 2.5 we will use this equation, and from 2.5 to 10 we will use this equation. So just put the values, you will get the shear force. Please check. Is it correct?
Yes. Yeah, it's correct. We take this Fy summation of Fy, V1 minus x.
Okay. So if these values are correct, then let's draw the influence line diagram. Okay, now this is ILD for shear at point C. Remember this. So at point C you have two values. When x is 0, it is 0. When x is 2.5,
Minus.
but again you have a positive value here, 0.25. Oh, sorry. 0.75 going to 0. So this is negative and this is positive. This is the influence line diagram for shear force at point C. If I move this point C from here to here, let's suppose I call it C dash.
What's the distance?
So how will be the ILD?
Starts from
It will be
The same diagram, but
That was it.
yeah.
but now
To the right is when the minus and the positive meets. Exactly. But the values may be different.
please check this. Okay, so this is the influence line diagram. This diagram is the influence line diagram for reaction at point C. Very simple. And see, there are two functions. One function is before this point, minus 1 over 10x, and one is after that point. Now, do you understand this diagram?
The same idea. But
Yeah,
you have
yeah.
the different 2 points.
Now this is section 1-1, the same thing. And this is section 2-2. Now next is the inference line diagram for overhanging beam. I just quickly go through this example from the slides. I hope you will understand. It's nothing different. Everything is same. So what is the question? Please draw the ILD at point C. The concept is perfectly same. Perfect same concept. So these are the values and this is a diagram. So you should practice this at your home. Or you want me to do here? Do you want to practice at your home or I should do it for you? We have some time, right? Okay. Okay, I quickly go through it. So we have two reactions. One is here, AY and BY. So this is our section. We have to draw the ILD for point C. So very easy. How much will be AY?
You take moment at the
It will be same or different?
different than the one before.
How much will be that? It will be the moment will be at point B. We will take moment at point B.
So
It will be
AY into 8.
AY into 8 will be 8 minus X.
8 minus 1
Yes.
minus x on the right.
AY will be 1 minus,
X over right.
and how much will be BY?
X over
X over?
8.
6
Yes.
Just 8 minus x. What's that? What
Into
you
1.
take here?
Into 1.
Into 1. Of course.
So it is same. Okay, now let's calculate the shear force at point C, BC. Now again, when the load is before C, the value will be different, and when the load will be after C, the value will be different. When the load is before point C, it means x0 to 4 meter. So BC, the shear at this will be reaction AY minus 1. So AY 1 minus x over 8. So it is minus x over 8. And when x is 4 to 12 meter, then VC will be, the shear at point C will be how much? 1 minus x over 8. 1 minus x over 8. Okay, let's draw it. So when x is 0, BC is
Minus 1.
what?
0.
0. When x is 0, BC is 0. And when x is 4, how much is BC?
Minus half. Minus half.
And when x is again 4 here,
0.75.
0.5.
Yeah, 0.5.
And when x is 8,
0. 1 minus 1.
and when x is 8,
12.
12.
Minus 0.25.
Check it. And x is 12, how much is BC? Can you see? Is it the same?
Yeah.
Okay, it's done. So ILD for the bending moment we will study in the next class. Okay? Yes, today I want to discuss something. Okay, so what about the groups?
How many groups?
How many? Yeah, just talking about.
Four students maximum.
Maximum 4 students.